Okay, welcome fourth graders to another screencast or a video test review actually, and we are going to be talking about electromagnets today. The first thing we should probably look at is what is an electromagnet. You can see a picture of an electromagnet here. It has a battery, okay, with a negative pole and a positive pole. Remember that negative and positive are attracted to one another, okay? And so the negative side is trying to get over to the positive side, and the positive side, because it is attracted to the negative side, wants to come all the way over to the negative side. So there is this constant going back and forth where negative is getting to positive and positive is going back over to negative. And it's going back and forth, this pulling and pushing, pulling and pushing. And the things that are traveling along this wire are the electrons. Okay? Remember, an atom is made up of protons and neutrons in the nucleus, and then the electrons are spinning around the nucleus of an atom. So the electrons are actually flying along this wire trying to get over to the positive, and the electrons are flying over trying to get over to the negative because they're attracted to one another. Now, as these electrons are going on this wire, the electrons also create a magnetic field. You can't see them because they're super small, but the electrons are actually coming off of the wire a little bit, and it's creating what we call a magnetic field. Now, that is strong with the battery in it. Now, if you put a piece of metal and wrap the wire around that metal core, the magnetic field becomes even stronger. Okay? The reason is the electrons, and here's kind of a blown up picture of what I'm talking about. You can see the electrons are going along this wire that's wrapped around this metal core, this nail. You can see it says electrons here. Now, as the electricity is going along this wire, the electrons, electrons, it's actually going to make the positive and negative parts of an atom. Okay, so the electrons go up and the protons go down. They're actually going to separate the positive and the negatives. Protons, positive. And neutrons are neutrons. Electrons are the negative ones. Okay? So what did I have here? I have red is negative. Okay, so the red is the electrons. Hopefully this isn't confusing, but the red is the electrons in this metal core. The yellow is the electrons on the circuit or along the wire. So I really should put red equals electrons also. Okay, but I didn't want to put yellow twice. So the red is electrons, and those go up there. I should grab a red marker real quick. Hold on a second. I don't want you to get confused, so let me go ahead and make another little key right here. Those are also the electrons, and the electrons are negatively charged. The blue is the protons, and those are positively charged. Okay, so the electrons going along the wire separates the electrons and the protons in the metal core. When the electrons and the protons become separated, this metal core becomes a magnet. So the wire is giving off a magnetic field. And now that this metal core has become a magnet because of the electrons flowing around it on this wire, the metal core becomes a magnet. And so now the magnet is giving off a magnetic field, and the wire is giving off a magnetic field, and that makes the magnetic field even bigger and even stronger. Okay, so hopefully that makes sense there. And there is a electromagnet. Now, moving on here, a microphone. A microphone is a device that uses a magnet to convert sound into electrical images. And you guys didn't want me to write this on the board because you were, we already have a lot of notes up here. But this is how it works. When you talk into a microphone, there is a diaphragm. It's a speaker. When the air comes out of your mouth, it moves the diaphragm up and down. Okay? Now, there is electrical field passing underneath the diaphragm. Okay? So the electrical charges, the electrons, the magnetic field is moving underneath the diaphragm. When I talk, that causes the diaphragm to go down, and that cuts off the signal. So, that goes down, that cuts off the signal. This signal, though, keeps going on, right? But once I stop talking, the diaphragm comes up, and then the signal continues again. So you have the signal going on, off, depending upon the vibration or how much air is coming out of my mouth. That's going to cause the diaphragm to go up and down, and it's going to be cutting off and letting go, cutting off and letting go this electrical signal of electrons and the magnetic field. That's going to create like a doot, 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 as it's getting cut off, all right? Now that message, doot, 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 those electrons are traveling along the wire. Now when those electrons, that message, doot, 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 right, it's getting cut off and letting go, cutting off and letting go. Once it reaches the speaker of another person, okay, it reaches the diaphragm of a speaker, okay, then the diaphragm moves according to that beat. Okay, so that beat's coming along, beep, boop, and beep, beep, beep. Now that signal is coming through the other end, and that's causing the diaphragm to move on the other end. So I talked, whoop, came out of my mouth, it cut the signal, whoop, and then the signal is going along, beep, 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 causing the diaphragm to move on the other end so the person can then hear my voice. Okay, so that's kind of how microphones work. That's how loudspeakers work. Microphones we already talked about. It's this cutting off and letting go of the electrical signal or the electron flow, which creates kind of like a pattern, which is then going to move the diaphragm. Okay, how it moves the diaphragm is the same thing that's going on with the magnetic field and how the magnetic field can get cut off. There is a pulling and letting go that is going on between the north and the south. So once that electrical doot, doot, doot comes along and it comes to this speaker, the pulling and letting going that's going on in that electrical signal is going to cause the diaphragm to let go. As it pulls the diaphragm. As it lets go of the diaphragm. And that's what's causing the diaphragm to move. This pulling and letting go attraction that's going on between the north and the south poles. Okay, so hopefully you get that. I know it's kind of a lot, but we've talked about it plenty in class. So this is just a review. I believe that's it. We talked about how to make it stronger. Electromagnets is a coil of wire wrapped around a metal core. So this right here would be an example of an electromagnet. We talked about microphones, diaphragm, A diaphragm is being pushed and pulled by the electromagnet. And how is it getting pushed and pulled? It's the north and south being attracted to one another, pushing and pulling. Loudspeaker. Electromagnets are used to make the sounds you hear when you listen to music on a stereo or watch TV. Well, I hope you've enjoyed this lesson on electromagnets. You're ready for the test. You've studied the vocab. You've asked any questions that you need to ask in class. You have your science packet all ready to go to be turned in. I hope this helps you, and I look forward to seeing you guys in class.